Between 500,000 and 700,000 kilotons of rice straw is produced per year, a majority of which is left to rot or burnt, producing greenhouse gas emissions and pollution. Biodigestion can transform this waste rice straw into a storable energy source for cooking and heating. To maximise the energy produced from biodigestion, rice straw can be mechanically broken down using a shredding mill. There are many ways to power and drive a shredding mill. We chose human power because it is a renewable, low-tech and dispatchable source of energy.
The two main methods of harvesting human power for motion are cycling and walking. We investigated the power transformation mechanisms and found that the mechanical efficiencies of cycling and walking are 5 to 20% and 25 to 40% respectively.
So, we decided to use walking to power our shredding mill.
Our design for harvesting human power featured a high natural gearing ratio, which eliminated the need for a gearbox, a flywheel for power smoothing, and a diameter of 2 meters to fit the 95th percentile of user heights. We theorized that using a circular treadmill would enable us to harvest power from the change in gravitational potential energy of the body's center of mass, as well as muscle power. However, gate analysis of the system shows that the gravitational potential energy of the upper body does not contribute, as the hip and shoulder do not move in the vertical direction. A prototype shredding mill was built to determine the most effective material for threshing rice straw. The results of testing showed that a combination of rigid metal bars and blades were most effective.
From analysis of the test results, several key optimizations were proposed. For the wheel, the tolerances in the base section were reduced to minimize friction, and handrail ergonomics were improved. For the shredding mill, the diameter of the mill increased from 300 to 800 mm. The gearing ratio was also increased from 2 to 1 to 3 to 1, and finally, steel blades and rods were used as the threshing mechanism.
Our final design output was able to shred 6 kilograms of rice straw per hour. If the system was powered for 6 hours a day, 5 days a week for a year, our design could produce between 8,600 and 26,000 kilowatt hours per year. This is enough to power 30 houses in a developing country.